All right, in the world of algebra, this is bread and butter type equations or solutions where early on in your mathematical world, maybe fourth grade or fifth grade, you would be given a question that looks something like this, where there'd be a box plus a number equals a number, and you say, well, what needs to go in the box? What plus 3 equals 7? And the student would think about it and say, let's see, I remember from my addition tables or from my addition flashcards that 4 plus 3 is 7, and the student would fill in the 4. And then as you got to 7th and 8th grade, the material moved more and more abstractly, where the box, the open box, would be replaced with a variable like x. And the question would be reformed like so, but the solution was essentially the same. Now, when the math is simple enough to where you can just look at it and see, that's one thing. But where you have to solve it is a little different matter. And so this next example, it's a little more complicated. 2x plus 5 equals 13. Now, you could think for a while about this and try to figure it out, but the simpler way to do this is to work from algebraic principles, where this is the way I describe it. I'm sure others have said this as well. Just make sure that whatever you do, you don't tell a lie. Whatever you do to the left side of the equation, to the object of this mathematical, the subject of the mathematical sentence, is also what happens to the object of the mathematical sentence to the right. This sentence, the subject, 2x plus 5, the verb is equal to the object, 13. Now, whatever we do to the subject must be done to the object as well. So the way this would work is we start from the outside and work in. What we want to do is get this multiples of the variable x by itself. And right now it's got this addition factor to it. So what we would do is subtract 5 from both sides of this equation. Now notice that minus 5 equals minus 5. So we're not telling any lies. Whatever we've done to this side of the equation is happening to this side as well. So we've added a new sentence. Minus 5, subject, is equal to minus 5, the object. We have a new sentence here, and it's a truthful statement. And now if we were to do the mathematics on this, 2x plus 5 minus 5 is 2x. And that's going to equal 13 minus 5. 13 minus 5 is 8. So now that's our new mathematical sentence. The new sentence is 2x equals 8. And now, to get x by itself, we have a term multiplied in front of the x here. So what we can do is divide both sides by 2. Again, to not tell any mathematical lies. So if we divide the subject by 2, we must divide the object of the mathematical sentence by 2. And 2 into 2 will cancel, leaving x all by itself. And we will find in the process that 8 divided by 2 is equal to 4. And so we find that x equals 4. That final sentence can be written as follows. X equals 4. Now, if we want to add additional layers to this, we can try a problem like this one, where these two terms here can be combined. You see, we have two x's here, and we can add 6 to both sides. So when we're done, we'll get 12x is equal to, and we add 6 to both sides to get rid of this minus 6. That's 24. So 12x equals 24. This means that x is equal to 2. And then here we have just a brief thing, again, very familiar within algebraic circles, is the distributive property. 2 times 2x, 2 times minus 3. We do it the first term and then the second term. So we have 4x minus 2 times 3 is 6. This is where you got to be careful, because I see over and over this mistake where a student will multiply the 2 times the 2x, and then instead of multiplying 2 times the minus 3, we'll just write down minus 3. But if you multiply 2 through this parentheses, the distributive property of algebra, or mathematics in general, is that if you multiply that through the parentheses, you've got to multiply the 2 times the first term and times the second term, or you've told a mathematical lie. Because this equation says the subject is 2 times this whole parentheses. So in order to do that, you've got to multiply 2 times each term within the parentheses. So that's 4x equals minus 6 equals 12. Now again, to prevent telling mathematical lies, we're going to work from the furthest away from x and work toward it. So that means we need to get rid of this term here. You remember that back in the principle of the order of operations, please excuse my dear Aunt Sally, that addition and subtraction were last. Well, when we're solving for x, we're going to work back the other way. We're going to start with addition and subtraction, move to multiplication, division, that kind of thing, and through the parentheses still. You still follow that rule. But what we want to do is get rid of addition terms or subtraction terms so that we can get x isolated. So in this case, we're going to add 6 to both sides. And this will leave us with the 6's will go away. This will leave us with 4x equals, in this case, 12 plus 6, 18. And so now we're going to divide both sides by 4. And we'll find that we have a fraction here, 18 over 4. That would reduce to 9 halves. And to me, that's a fine answer there for x. The 4's will cancel. So x is equal to 19 halves, and you could write that as 4.5 or 4.5, but I wouldn't. I like the 9 halves like that. 9 halves is a usable number that you can then use somewhere else. If you make a mixed fraction out of 4.5, now you have to, if you were to use it somewhere else, convert it back to the fractional term 9 halves in order to be able to use it. So this is a fine answer, 9 halves. Now 18/4 is not incorrect, but in mathematical world you always want to simplify, and so the correct answer is 9 halves. Now these are easy to check. These are easy to check. For instance, let's go back to this one here. We can put 2 back in here. We'll have 2 times 7 is 14. 2 times 5 is 10. 14 plus 10 is 24. 24 minus 6 does equal 18, so we can check it. So it's easy to check these problems. And let's do it here where we have x equals 4. 4 times 2 is 8. 4 times 2 is 8 plus 5 is 13. So we can check these things. And so you can put the numbers back in and check to make sure that the algebraic equation actually doesn't tell a lie when you get the answer at the end. And you should do this on the test. You usually have plenty of time. I find on average it takes about 40 minutes. You have a 55 minutes of allotted test time. And on a problem as simple as this, to put that number 4 back in the equation take you all of 30 seconds. And if it's not right, then you start looking for, where did I make a mistake? What went wrong? And so anyway, I would check these. All right, now let's work just a couple more of these problems. And then we'll be done with this section. This is, again, items that should be very familiar to you. Now what I would do is spend quite a bit of time practicing so that you're ready to go when it comes time for the test. Now let's try this problem here. So let's see, 2x plus, and then we have in parens, we have 2x minus 3 equals 5. That's a fairly straightforward problem. The parens there, don't let that detract from what's taking place. There's no multiplication in front of it, so that is just 2x plus 2x minus 3 equals 5. Now you'll see that those two terms can be combined. I think there's 4x. And we can add 3 to each side. And that will leave us with 8. We'll have 4x equals 8. This means that x is equal to 2. Because if we divide 4 into both sides, we get x equals 2. And again, to check this is very easy. 2x times 2 is 4. 2x times 2 is 4. 4 plus 4 is 8. Minus 3 is 5. So we can easily check that. Now let's do another problem. We have minus 2 times x plus 5. And we have that is equal to 30 minus x. So we have minus 2 times x plus 5 equals 30 minus x. So the first thing we do is distributive property, right? Minus 2 times x is minus 2x. Minus 2 times 5 is minus 10 is equal to 30 minus x. Now we want to get all the x's together, right? We want to get all the x's together. We're going to combine all the x's together. And that way we can isolate x. Can't isolate it when there's x on each side. So the easiest thing to do here is to add x to both sides. And that will give us minus x minus 10 is equal to 30. And now it would appear that adding 10 to both sides would be helpful, because that will get this x term by itself. That will give us minus x is equal to 40. Now be really careful there, you don't lose that minus sign, because minus x equals 40, and we can divide or multiply by minus 1, and what this will give us is that x is equal to minus 40. Again, a problem that should be very easy to check. Minus 40 plus 5 is minus 35. Minus 35 times a minus 2 is 70. 30 minus a minus 40 is 70, and so that does check out. And so that's the correct answer for that. So now here's my recommendation. There's a lot of aspects of algebra that have been introduced here. And you should definitely do a lot of practice problems. One of the things that's been introduced here, though, is the concept of distributive property, the concept of combining like terms. These things are very important throughout this class. So for instance, if you have 3 times 2x plus 4 plus 2 times 3x plus 3, if we want to simplify this, what we do is distributive property here. That gives us 6x plus 12 plus 6x plus 6. Those terms can be combined because they're both an x term. So that gives us 12x. And these two terms here can be combined. 12 plus 6 is just a constant. No variables involved at all. No other terms other than just the actual numbers themselves. 12 plus 6, that's 18. And so that gives us the simplified term there to this. So the distributive property is very important. We'll see it throughout the semester in almost every single chapter where you're having to, in order to solve for a particular equation or to graph a line or anything like that, you'll have to use the distributive property where you take this term, multiply it through the parentheses, and just be really careful. This is about paying attention to detail. Much of algebra is about paying attention to detail. The math itself is usually not that hard. What is more difficult is keeping track of the basic operations, not losing terms in the process, not failing, being careful to not fail on distributing against all the terms within the parentheses. And so 3 times 2x, 3 times 4, those kinds of things can really get you in trouble if you're not careful. And so I would just emphasize this as you work through the homework in this section. This is the only section for this particular day and lecture. And the reason for that is that I want you to be able to really focus in on doing all the practice problems, combining the terms, simplifying each expression, and then as you work through the section, then eventually solving for x by getting x or y or whatever the variable is isolated by itself. That basic mathematical concept will then be critical to the rest of the semester. So if you don't master this, I would venture to say you'll be in a lot of trouble for the rest of the semester. You have to master this. You have to bear down on this, focus on this, do extra problems, ask questions, whatever it takes, rewatch the video, make sure you understand these things.